was, oh, so a specific, I found one from like the old homework.
Sure.
And it was, so it's 1 centered at 1.
Okay, centered at 1.
And it's x natural log of 2x. And it's going to, it's 3 Taylor. Or 3
Right,
of
so
them.
you're doing a T3, right? Okay, so go that way. Now let's do the, start with f of x, which is x natural log of 2x. So since you're centered at 1, we'll need to find f of 1. So that's basically just log 2, which is rather ugly, but never mind. This guy's messy. You've got to be careful. That 2x is actually more dangerous than you think. Would you be comfortable that that's a product rule? So it's going to be f dash g plus f of g dashed. And that's going to be 1 times the natural log of 2x plus x times, and this is where the 2x gets really sneaky on you. Differentiating the natural log gets you 1 over 2x, but don't you also get times 2 because it's a baby general? So what you end up with is the natural log of 2x, and the x's cancel, and you're left with 1. You weren't expecting that, were you? So let me double check that I didn't screw up there. F dash g plus f of g dashed. And the x's cancel and 2 cancel, that's it. So f dashed of 1 ends up being the natural log of 2 plus 1. So I need to do the second derivative, which is going to be 1 over 2x times 2, and the derivative of that don't matter. The 2's cancel and you get 1 over x, and f double dashed of 1 then ends up being 1. And I think we've got one more to do. If you differentiate this guy, you get negative 1 over x squared, and the third derivative at 1 gets you negative 1. Are you happy with the first, second, third derivative and the value at 1? You comfortable with all those? Right, so really it's just plug and chug now. It's going to be f of 1 plus the derivative at 1, x minus 1 over 1 factorial, second derivative at 1, x minus 1 squared over 2 factorial, and lastly, third derivative at 1, x minus 1 cubed over 3 factorial. So all I'm going to do is plug in numbers and try and make it pretty. Right, that guy's log 2. This guy is the natural log of 2 plus 1, x minus 1. Over 1 factorial is over 1, so I don't really need to worry about that. The next one is 1, x minus 1 squared over 2 factorial, which is 2. And the next one is negative 1, x minus 1 cubed over that, and it's 6. You typically just leave these guys alone. So that guy, this really ugly thing gets left alone. I'd call that a half x minus 1 squared and take away 1/6 x minus 1 cubed. Is that what you were thinking about?
Yeah, and then when you do the remainder,
okay, so
errors.
the WebAssign does the remainder differently from what I'd expect you to do. They have a really ugly formula. This remainder, I'm assuming there was an interval attached to this question.
Yeah, there was. It was 0.5 to 1.5.
Okay, so what I suggest you do in that particular situation then is we know what the remainder formula is, and no matter how you do it, it is this formula. It's basically the value of the function, right? Take away t3 of x, and we stick an absolute value to make sure it's positive. And when you are dealing with this question, then it becomes natural log of 2x, that's the function. Take away Can I just say dot, 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 dot? Because basically you take away that entire ugly mess. And what you then do is that at the two endpoints, that's where the biggest error happens. Because if you graph these things, you tend to get something that looks, well, depends where 0.5 is here, right? And 1.5 is over here. It tends to look like some kind of U shape. And what that is telling us is that the biggest value of the errors is always typically at the two extremes, right? So you can plug that into your calculator, or you could just simply find the value of this ugly mess at 0.5 and the value of this ugly mess at 1.5. And whatever one of those two is the biggest, we would say that is the maximum error you could get. So if I was doing this one, it would be 0.5, the natural log of, well, 1. Take away a whole load of stuff, which is basically all of this, where x was 0.5. And that would, God, you've hit buttons and eventually you get an answer, right? So no guarantees, but let's pretend that's what this one was and that's what that one was. The bigger of the two answers is your error. And that's how I would suggest that you do the R3 error function. If you try and do it the other way, why do I like this? Well, one is numerical, which I don't normally like, but isn't this exactly the worst case scenarios? You can guarantee that. If you use that formula, you know, the one that does the next derivative x minus a, if you do that one, you have to estimate the largest value of the fourth derivative. And isn't that itself an estimate? So it's not like they're giving you a better answer. So that's my argument for why this is okay, even if that's not the way the textbook would do it.
Thank you.
Okay. Where are we off to next? Oh, before we do that, let me show you something I've got set up here. If I got it handy, I do, good. I don't know if you've been to Canvas lately. Let me show you some of the resources that I now have. You should be looking at our Canvas page. Maybe make it a little bit bigger. Right, final exam for us tomorrow. Starts at 7, finishes at 10. If you come in a little bit early, that's fine. I'll probably be here and I can unlock it for you if you want an extra 10 minutes at the start, if you think you're going to need it. If you click on this fella here, I've basically written down the Zoom link, the topics, and you know what you're expected to do. If you click on that, there's your Zoom link for tomorrow. If you click on that, there will be a PDF with your final exam in it. You know that the final exam is 10 multiple choice. I don't want to see working for. I just want to know A, B, C, and 10 questions, just like normal exam questions, which I do. I have put a variety of software which is going to stay here, because sometimes don't you need to see the thing, right? You want to do it. So I've put all sorts of parametric curves and Desmos in there. And there are 2 practice finals with solutions. If you click on the first one, and there'll be quite a lot of overlap because I'm sure I used the same questions more than once. And God, it takes ever and a day to do this. There we go. And if you scroll far enough down, and can you see there's solutions, right? And then I've got another one, which I think is different. I'm not 100% sure now. It's larger anyway. Yeah, it is larger. Yeah. So, and if you look at this one, can you see, yes, there's more examples. And that's basically just it, right? So some of the later sections didn't get covered in that first practice final, so I found a better one. I think I did, yeah. So can you see there's some partial derivative stuff as well. So that is just a resource. Pretty much everything you see here will be here, except for obvious reasons, 2 practice finals, and everything else will have gone. So remember, you got to write it down. If you can't, if you don't write it down and you don't memorize it, it's going to be a problem, isn't it? So make sure you have very, very good notes. Right, next question, next topic. Anybody got some for me?
Can we go over 3 of the multiple choice questions from the first practice final, the smaller document?
Sure.
So yeah, I wanted to go over 9, 10, and 19.
Okay. Okay, there's 9. Try and make it a little bit bigger. Yeah. So it's the arc length of this fella from 0 to 1. That's the question, right?
Yes.
Okay. Do you know the formula for calculating the arc length, whether it's a 2 or 3 dimensional function? Can you remember the formula?
Not off the top of my head.
Okay, then let me show you the formula and then I'll do the rest of the question on the whiteboard so you can see. Well, I suggest that you write down this formula. The one that I'm doing right now is the integral from a to b of the square root of dx by dt squared plus dy by dt squared dt. Now, if it's a 3-dimensional one, so a space curve in 3 dimensions, it would be that guy. Not that I would ever do it, but if I asked you for a 4-dimensional one, can you imagine the formula would just generate another term, right? Now we're using the top one. So it's going to be the integral from 0 to 1, because they tell me that's the start and finish. The square root of, and x happens to be 1 plus 3t squared. So the derivative of this is 6t, and then you square it. And then the other guy, and the y, is 4 plus 2t cubed. So if you differentiate that guy, I believe you get 6t squared, then you square it. Now we've got the integral from 0 to 1. If you square this guy, you get 36t squared. If you square this guy, you get 36t to the 4. And we're looking at that. Okay, we need to integrate this guy. Algebra's your friend. Can you tell me anything you might want to do with this to make it pretty?
We simplify it to 36t plus 6t squared.
1 plus 6t squared. The
Is
middle
it
line,
6t
right?
outside of there?
It'd be 6. You're right. It's 36t squared, 1 plus 6t squared. And then you pull that out, you get 6t. Let's do that again. You pull this guy out, and you get 6t. And this is the guy that's left over. So that was a good start. Where else do you go now? What method are you going to use to integrate 6t 1 plus 6t squared?
Calculator.
Actually, yes. If you wanted to do it exactly, couldn't you do a u sub 1 plus 6t squared? And about 5 minutes later, you get the right answer. On the other hand, couldn't you just plug that into the calculator? And if your answer was 1.414, wouldn't that be the same as the square root of 2? In which case you would pick that particular guy as your answer. Now, the choices that you do get are A, B, C, D is undefined, which I'm throwing out, and E is some other answer. Now, I don't know what the right answer to that one is, so I'll scroll down to the bottom and tell you, and then I'll check on my calculator that I actually told you the truth. So, question 9, according to the solution, was E. So that's some other answer. So I would go to my calculator. I do y equals. Remember, when it's multiple choice, all shortcuts are valid. Would you agree that getting your calculator to do it's a shortcut? Right, so it's going to be 6t, which I'm going to have to call 6x, the square root of 1 plus 6x squared. I'll do a window from 0 to 1, and I'll do a zoom effect to make sure I didn't screw anything up. And then I could do second calc number 7, start at 0, finish at 1. And so we get 5.8400, that's probably enough. And then I'm assuming that if you checked all the choices, the ones that had numbers, none of them fitted. And that's why it's E, some other answer. Rosie, you have your hand up.
Yeah, I was just confused about how you went from square root of 36t squared plus 36t to the 4th. So you went from that to 36t squared times 1 plus 6t squared.
Oh, darn it, I'm far too fast for my own good. Is that what you hoped it would be?
Yes.
Right, well, then I should fix this. And so I shouldn't go fast. It's just not a good idea for me to go fast. And the corrected value is 3.6568, and evidently none of them fit either. The good news is that if you'd done my mistake, wouldn't you still get the right answer because it was B in both cases? So multiple choice can be quite forgiving at times. Now, the other one was what number?
Number 10, please.
Okay, so what we have here is a hyperbola, not that you need to know that. And you are given 5 different guys, parametric possibilities. So I'm picking A, and A is 2 secant t, and Y is 3 tan t. And all I'm going to do is plug them in and see if it works. 2 secant t squared over 4, take away 3 tan squared t, 3 tan t squared, get it right, over 9. Okay, so 4 secant over 4, take away 9 tan squared over 9. That becomes secant squared t, take away tan squared t. Right, is that equal to 1? Okay, tell me any one of the 2 trig identities that use secant squared and tan squared. What's the connection? Secant squared and tan squared.
Isn't tan squared plus 1 equals secant squared?
Okay. If you rearrange this one, don't you get it? And it matches. If you had done this question, but it was -1 here, right? Let's just suppose a -1. Wouldn't you go looking for a guy that looks like that, but with some negatives involved? If it came to something that had nothing to do with it, wouldn't you probably avoid the secant and tan choices and look for some other choice? Once you found the one that works, isn't it basically don't bother? Right, they're only one to find. That would be it. Rosie, I don't know what the answer to that is, so let me find out. Well, I do. That's it. The answer to that should be A. And let's check it. And it is A, so that's the right one. When you do multiple choices, think of shortcuts, right? Like use the calculator rather than get the whole answer. In this case, didn't I just randomly pick one and see if it worked? And if it worked, great. And if it didn't, wouldn't I use the one that failed to maybe give me a hint not to use this other guy as well? Because if that one didn't work, the other secant and tan wasn't going to work probably, you know, that kind of thing, or whatever. Rosie, any questions? You got your hand still up.
Thanks for going over that one. Can we go over 19? And that's the last one for me.
Okay, 19, multiple choice. I think I'll zoom back to show you because I'm not in space. Nineteen. Okay, well, actually it's probably easier if I just write it down because it's quite a short question. They want the vector function, right, which is another name for the space curve, that represents the curve of intersection of a sphere, which is this guy, and a plane, which is this guy. Now, when you look at your choices, A, B, C, or D, there's already a clue. All of them except the some other answer starts with that. So I'm going to use that as my clue. I'm going to make X equal T, right? In some questions, it's Y equals T, and others you decide Z equals T. But pick one of the three and call it T. Right. Now, if you rearrange this, isn't Z -X? And if X is T, does it not make Z -T? Now, since I know what X is in terms of T and Z is in terms of T, can I now go here and replace the X with a T and the Z with a -T and get T squared plus Y squared plus T squared is 100. So Y squared plus 2t squared is 100. So y squared is 100. Take away 2t squared. And what should I do to both sides to get y?
Square root it.
I would take the square root of it. And unless there's other information to tell me otherwise, I typically, don't we always pick this positive square root if there's no other information? And that happens to be, what does that happen to be? 100 minus 2t squared. That happens to be A, I believe. Technically speaking, shouldn't I say plus or minus this? But we'll assume that we're only talking about the positive, the above the XY plane. Right. Are you good with that, Rosie?
Yeah, thank you.
Okay. Give me a topic, give me a question, whatever it is. Oh, did you all get your report? Before I forget. Your reports, everything that includes your attendance for today, whether you turned up or not. It also includes all your homework, all your extra credit, I mean, everything. So the only thing that is left now is what you're going to get in the test. So check it in case there's some things I need to do. We're not even taking attendance today, so if you don't even need to say hi.
Convenient that you put the amount you needed to score to get a different grade on the final report.
Sorry, Tim, I didn't catch the end of that.
It was handy that you put the amount you needed to score on the final in order to get a certain grade on the end of the report.
Yeah, because of the last homework being added, there would be a slight difference, so I thought it would be worthwhile. I actually found a pretty quick way to do it in the spreadsheet, so it wasn't actually too much work for me to do. I didn't want to do it the first time because I couldn't think of how to make it happen, except do each one individually and write it down, which wasn't my idea of fun. Have we any other questions? Maybe we're questioned out.
Is the extra credit from last night's homework supposed to change our grade or not? Is it?
It should be added and included.
Okay, because I did it and it didn't change my grade.
We have got so many points in that unless something's a major thing, it probably didn't. It probably went 0.3 to 0.4 and you never saw anything because it gets rounded off. So.
Okay, that makes sense because we're so far into the quarter that.
Well, yeah,
any difference is
you'd have to get
negligible.
4 zeros before it would really do any damage. Well, maybe
Okay.
2 zeros would do some damage, but an extra 0.5 doesn't really round off much, so it probably didn't matter.
I wouldn't. I mean, you could show me that question that I had a question about specifically on the homework from.
Okay. Have you got it handy? Could you tell me what
I
it
can
is?
probably have it handy.
Okay, I'll wait for it.
That's a terrible picture. Can you hear me?
I can hear you.
Okay. Let f of x, comma y, comma z equal natural log of z minus the square root of x squared plus y squared. And it was find the domain.
Let's try this.
And I had entered the domain as.
Whoa, wind back. It's z, take away the natural log of. I didn't get the last part.
Square root.
Oh, it's not a natural log, is it?
No, it's
Which is-
natural. It's the natural log, and then it's the natural log of z, and then this is all in parentheses, minus square root of x squared plus y squared.
Okay. If what I've just written is correct, then we'll move on. Is that it?
Yep.
Okay. Now, when you look inside a natural log, the condition that has to be met is that the thing inside has to be greater than 0. So
Yep.
you will write down that guy. You do not need to write this guy down, which is what you would typically do for a square root. But why is that redundant or unnecessary?
Because it's already in the first part. Well, so that's probably why I
Not
got the question
directly.
wrong.
Because both
It's
terms are squared and they're added
Yeah.
together.
and they're always going to be positive. So there's no way that that's not going to be okay. Right. So basically, there's only one restriction, and
Wow.
it's that one.
All right. Well, that's answered my question.
Give you a different version of that question. If I went and gave you that one, and then I gave you a different function, very similar looking, and I gave you that one, this one here, you're basically your answer. Well, I guess I should put z squared on. There we go. This one, your domain would be all real numbers, r cubed. R is for one-dimensional real. R squared means, everybody in 2 dimensions in r cubed. But this one has a restriction. But it's a square root, so it has to be greater than or equal to 0. But if it was a log instead of a square root, we make it greater than 0. So it's those little, WebAssign will definitely bite you. If it wants an equals to and you've only gave a greater than, or vice versa, it's going to tell you you're wrong, even if 99% of what you wrote down is correct. Right, you'd write, you put an equals there instead of a greater than equals, that kind of thing. That helped, Tim?
Yeah, you've
Okay.
answered my question.
Well,
So I put both limits in. I put the one that you wrote down and the one you wrote down and crossed out. And I think that's why I got it wrong. I was trying to figure that out.
Yeah, in the big scheme of things, these aren't going to dent your grade at all. They're just, I think it's
No,
like
I just want to know.
20, yeah, I hear
In
you.
case it's on the final.
Yeah, they're 24. Yeah, if this was on a final, I'd probably make it a multiple choice. It's one of those you can give four choices, one of which is, of course, correct. Anybody got another question? We're getting good stuff here.
I said a quick question. So if we did the chain rule on that with respect to Z, how would we do that?
What the function of just this one here?
Yeah, I've just been struggling with the 3 variable one.
Okay, so let's suppose we start with this guy. And I'm assuming what you're talking about, I don't know if you would call it the chain rule unless X, Y, and Z were functions of T, in which case it
Okay.
would be.
Yeah.
Is that what you're talking about?
Yeah, just I guess
Okay,
that section in general was
so let X be, say, sine T, right? Y be e to the T, and Z be T squared plus T, right? Just for argument's sake, right? So then you might get a question where they ask you to find the derivative with respect to T. Right. So as a chain rule, that would be the partial derivative of f with respect to x times dx by dt plus the partial derivative of f with respect to y times dy by dt plus the partial derivative with respect to z times dz by dt. Do you notice some of them are partial and some of them are solid? It doesn't really change what you do, but be precise, we should. So each one of these is, well, let's do them one at a time. If you want to differentiate this function with respect to z, you are going to get 1 over the guy, technically, times the derivative with respect to z. Well, the derivative of that is 1, so I don't need to do anything. And dx by dt gets me cosine of t. So that would be that piece done, right? Now, the middle one and the end one are going, oh, shooting space. That's the answer to here. I just did dz by dt in the wrong place. Right, pretend I didn't do that. So, from the top, each one of these guys is going to be found, and then we'll combine all the pieces. Right. That guy is him. I just put him in the wrong place. Okay, now, if you differentiate this with respect to x, it is going to get really, really ugly. It's 1 over the guy, which isn't too bad. But then don't you have to differentiate what's inside the brackets with respect to x, which means you probably want to call that x squared plus y squared to the half, which means you're going to have 1/2 x squared plus y squared to the negative 1/2 Oh, and it's negative as well. So negative 1/2 x squared plus y squared to the negative half times the derivative of x squared plus y squared, which is 2x. So the 2 in that cancel. And you have got 1 take away x over the square root of x squared plus y squared all over z take away the square root of x squared plus y squared. I don't think anybody would ever give you one that ugly.
Wait,
But,
would
I
you
mean, that would
multiply
be the
the one?
process. Say again?
Would you multiply the one?
If I wanted to make this prettier, I would combine the top and then drop the
No.
x squared.
I mean, like, isn't the second term negative 1/2 times x squared plus y squared to the negative half times 2x? Isn't that multiplied by the 1?
It's a 1 takeaway this
Instead
case.
of, wait, how'd you get the takeaway then?
Okay. I'm doing the derivative of this guy with respect to x. So it starts off with this fella, right? Times, right, the derivative with respect to x of what's inside. And this guy, that negative 1/2 x squared plus y squared to the negative half times 2x. And if you're wondering where all of this comes from, if you take this fella and you want to differentiate him with respect to x, you'd have to write it down like that. And so what would I get? Nothing for that. So that's why there's nothing here. Negative 1/2, that's where that came from. Reduce the power by 1, which is where that came from. And then differentiate what's inside with respect to x, which is that one. Which is why we now have this guy. Technically it's 1 times that, so they cancel out. So what do I get? I get a negative x. Actually, it's a little bit prettier now that I've done it a second time. It looks like that. I would have this guy comes downstairs as a square root. And then 20 minutes later, we'd finish that question because there is a lot of different moving parts. I don't think you ever got one that was anywhere even vaguely as ugly as that. Can I choose a different version of that question that is more realistic?
Yeah, that's fine.
Right. So let's suppose we do a function that is basically just an x squared plus a y squared take away 2z, right? And we'll keep these guys because they're reasonable. Sine t, e to the t, and t squared plus t. And the derivative of f with respect to t then is the partial derivative with respect to x, dx by dt, plus the partial derivative with respect to y, dy by dt, plus the partial derivative with respect to z, dz by dt. That guy gets you 2x, the derivative of this guy gets you cosine t, right? That's much cleaner, right? This fella gets you 2y, and the derivative of him is e to the t. And this guy gets you negative 2, and the derivative of this guy is 2t plus 1. So what we need to do is make this look a little bit prettier. And all I'm going to do is replace the x with sine t. So I get 2 sine t cosine t. I'm going to replace the y with e to the t. So I get 2 e to the t, e to the t. And this guy here is already pretty nice. I'd recognize that as the sine of 2t. I'd recognize that you can multiply them to get e to the 2t. And that would be your answer in terms of t. That's a much cleaner question, more realistic as well.
Thank you.
Right. Now, pay attention to the way, excuse me, a question like this could be phrased. it could say find the f by dt and give your solution in terms of t. And that is the answer. Sometimes aren't these questions so ugly that you are allowed to leave them as combinations of x, y, z, and t's?
Yeah.
So if you do not see this sentence, assume that you're allowed to leave it as x, y, z's, and t's. That makes sense? So if you're not told x, y, z's, and t's are allowed to be mixed up, if it specifically says it wants it in terms of t or s and t, if there's two variables going on, then you need to do that.
Okay.
Wow. Time shoots by when you're enjoying yourself. I will see you early tomorrow. What time will I see you tomorrow? That's a good question. I will see you here at 7 or a little bit earlier if you want. And good luck. And have fun. Bye-bye,
Can I
guys.
ask-
Yeah, go for
Can
it.
I ask another question?
Go for it.
So I have difficulty finding the error of Taylor series.
Yes. I think you may have come in a little bit late, so you missed it, because that was essentially our
Okay.
first question. But I've got pretty much the question here, so talk you through what would happen. Right, so you're given your function, and let's assume that you found t3 of x, and it ends up being this guy. So I think most people, this isn't the problem, right? Finding t2 of x or t3 of x, it just takes time. The process
Okay,
is
and
pretty
is
simple.
that centered at 1?
Yeah, this one is centered at 1, right?
Okay.
So this is t3 of x tidied up. Now, the way I want you to do the remainder isn't the way that the textbook asks you to do it. Simply, you are just going to use this formula. The function take away t3 of x. The absolute value between these two is essentially the error at any given value of x. So it would be x log x take away this horrible mess. Now, we know from experience that if you draw it, it tends to look like a big U shape. Have you noticed that all these, if you type this in without the absolute value, they look like big U shapes, or they look like some kind of x cube shape. The bottom line is that when you're talking about the maximum error, don't they always occur at the endpoints? Right, at 0.5 and 1.5 in this case. So all you do is you find the value of this expression at 0.5 and the value of this expression at 1.5, and whichever of those two is the larger, that's going to be your remainder error. And I argued that I like this better than the textbook one. The textbook one, you have to find the fourth derivative. Not only that, you have to find the maximum value of the fourth derivative in this range. And very often you have to estimate what that is because you don't know for sure. And so even their technique has error in it. Whereas isn't this technique, although it's numerical, isn't it perfect? Because that is the worst error you're going to get. At least it's perfect as far as the accuracy of your calculator is. But that's true for every method.
So I'm a little bit confused. How do you find the maximum if there is one?
You will find the remainder at 0.5, and you will find the remainder at 1.5, whichever one of those.
I'm saying if it was curved the other way. So if it curved
Wouldn't
up
matter.
and then,
Wouldn't matter one bit, because it's the absolute value of these, and the bigger of the two is the maximum error. So if your error function looked like this, right, and that number there was say 0.007, and this number down here was negative 0.03, wouldn't this be bigger when you take its absolute value? So this would be the maximum error.
but what if it was like an upside down parabola?
Wouldn't matter, you'd get the exact same result.
Really?
Yeah. suppose it was an upside down parameter, right? Put in maxes. And this guy was negative 0.3, and this guy here was negative 0.7. Wouldn't that be the biggest value? Absolutely.
Well, couldn't the peak be at that top point? Or couldn't that be like 1?
It could be, but it won't, because you get the most error is furthest away from the center.
Oh,
So I'm just
Okay.
using a property of experience. We know that when you do these functions, the worst scenario is right at the extremes. Would you agree right in the middle isn't the answer tiny?
yeah.
You know, at 1 and 1.1, the answer is tiny. By 1.4, the error's a little bit bigger, but by 1.5, because that's when we're finished, that's when the error is going to be. So
Yeah, that makes sense.
we're making the assumption here that based on experience, the boundaries, right, the beginning and finish values of x's are really the only two places you need to look if you're interested in the most likely location of the worst error. Now, does that mean there's not some weird, wonderful function out there? Sure, there is. But if you use the other method, you wouldn't find that guy. You wouldn't find the right answer with that guy either, right? I mean,
I think that was the piece that I was missing. So I think
Right.
that helped a lot.
right. So